For this video, we are going to discuss the concept in probability chapter, which is independent events. Alright, so what is the meaning of independent events? If let's say event A and B are independent to each other, that means the outcome of one event does not affect the outcome of the other one. So we call them as independent events. Alright, so please take note that independent events are not similar with mutually exclusive event. Mutually exclusive event, you can actually try to show it in a Venn diagram. So like this one, we call them as mutually exclusive event. But for independent event, these two events are not affected by each other, and you actually cannot show it by using Venn diagram. Alright, so you have to understand the difference between these two. Mutually exclusive means that they will not overlap, but for independent event means that the outcome does not affect each other. Alright, so for independent events, there's one important formula that we will apply very often, which is A intersect B. You write it is equals to probability of A multiplied with probability of B. Alright, so usually I will remind students, if let's say you want to apply this formula, you have to make sure that you are sure that the events happen in the question are independent. If let's say the question didn't mention that they are independent, or you're not so sure whether are they independent or not, please don't use this formula. Right? Okay, so for independent event A and B, the conditional probability that given that A already happened and we want to find the probability of B is equals to PB and the other way around. Alright, so for this point, generally we are not going to use it very often. Okay, so you can just skip it. It is just for extra knowledge here. Alright, then for the next one, when A and B are independent, that means all the complement events between them and are also independent. Alright, so in short, for any independent events, the outcome will not affect each other. And the other important point is the formula that we use for all the independent events, which is A intersect B equals to A multiplied B. Alright, so let's have a look for the example that related to independent events. Okay, so please read example 13 before we start. Alright, so they are talking about the mathematical puzzle solved by 3 students. Alright, and then from this question, there's one very important keyword you need to highlight, which is without consulting each other. So when they solve the math puzzle and they actually didn't consult each other, that means their result will not affect each other. And this also concludes that all this belongs to independent events. Alright, so when you know that they are independent events, which means you can apply the formula A intersect B. If you want to find the probability for A intersect B, you can directly use the probability of A multiplied with probability of B. So you actually need to figure out yourself whether that question belongs to independent events or not by looking for some keyword and the meaning of the question, right? Okay, so first, they talk about the puzzle will be solved correctly by all of them. If let's say the puzzle is solved correctly by all of them, that means Alicia answer the puzzle correctly, intersect with Amy, answer the puzzle correctly, and intersect with Alice, answer the puzzle correctly. Alright, so since I know that all these are independent events, therefore I can straight away find out the probability by multiplying all the probability of them who that answer correctly. So that means when Alicia answered correctly, the probability is 0.65. Then I can straight away just put a multiply. Amy correct is 0.6 from the question, and after that Alice answer correctly is 0.55. So when you simplify this, you will get the answer 0.2145 or 0.215. Alright, so I can apply this formula directly because of the keyword without consulting each other. So from here, I know that they are independent events. Right, then we proceed to part number 2. Only one of them will get the correct solution. If let's say only one of them get the correct solution, what are the possible cases that we have? If only one of them correct, means that maybe Alicia correct, intersect with Amy is wrong, intersect with Alice is wrong. Or you can have the other cases where Alicia is wrong, Amy is correct, Alice is wrong. Or the third case is Alicia is wrong, Amy is wrong, but Alice correct. So all the three cases here belongs to only one of them answer correctly. Alright, so for the first case, Alicia correct, Amy wrong, Alice wrong. So when you write out the probability, it will be 0.65. That means Alicia answer correctly. Amy answer wrongly will be 0.4. Alice answer wrongly will be 0.45. Plus, the next case. For the next case is Alicia answer wrongly, it will be 0.35. Amy answer correctly is 0.6. Alice answer wrongly is 0.45. And the third case is what? For the third case is Alicia answer wrongly, 0.35. Amy answer wrongly, 0.4. And Alice answer correctly is 0.55. So you just multiply the probability straight away to complete a case, and you plus the probability for the other cases. Alright. And if you simplify the whole thing here, all the things here, you'll get answer 0.2885, or you'll get 0.289. So this question, they give you a very obvious keyword, which is without consulting each other, that tells you that this question belongs to independent event questions. Therefore, to find the intersection between all the events, you can straight away multiply the probability of the events themselves. Alright. Okay, then next, let us proceed to the other example. Let's have a look for example 14. It is a two-way table again. Alright, so now, if you go through the question, you realize that it is a two-way table question. Therefore, before you start answering the question, please get all the marginal total and also the grand total for this table. So for unemployed is 564, employed 717, male 618, female 663, and the grand total is 1281. Alright, so once you completed all this figure already, then you can try to answer the question. First part, find the probability of M. What is the meaning of M? M is the event that the person is male. E is the event that the person is employed. Alright, so they want to know what is the probability that a male is chosen. Okay, so to get the probability for male is chosen, get the total for male, which is 618, divided by the grand total 1281, and from here you'll get 482. Right, so this is a very simple and straightforward question. All right, then we proceed to part number 2. They want you to calculate the probability for M intersect with E. All right, so for this question, if let's say they want you to find the probability of M intersect with E, if you are using this formula, the probability of M multiplied with the probability of E, then you will not get the correct answer. Why I cannot apply this formula in this example? The reason is because if you read through all the whole question here, you actually didn't see any keyword that tells you that the events here are independent to each other. Therefore, you are not sure whether are they independent or not, you cannot apply this independent formula. All right? Okay, so this is not correct. Therefore, if you want to find the intersection between M and E, again, please look for the correct figure from the two-way table. So M, male intersect with employed is this one, 412. Therefore, you should have 412 over the grand total, which is 1281. You will get 0.322. All right, and third part is something that we want to focus on. Now they ask you, are M and E independent events or not? And justify your answer. So usually when they ask you this kind of question, you actually need to find out two values here. First, please find out the probability of M multiplied with the probability of E. So what is the probability of M just now? 618 over 1281 multiply with the probability of employed. So it's 717 divided by 1281. And from here, I think you get 0.270. So this is the first value that you need to find out. And the second value that you need to find out is M intersect E. And this value already get it just now in part number 2, which is 0.322. Alright, so to check and see whether are they independent events or not, what you need to do is like you have to compare these two values. Alright, so for this example, if you compare these two values, they are not the same. Therefore, you can write it as the probability of M intersect E is not equals to the probability of M multiplied with the probability of E. So which means the conclusion for this is M and E are not independent. Alright, so in the other way, if let's say when you compare these two values and you realize that they are the same, so you can write as equal sign. If the value are the same, then you can write as equal sign, and your conclusion will be M and E are independent. Alright, so this is the way that we justify whether M and E are independent events or not. Right, you have to compare the probability for M intersect E with the probability of M multiplied with E. Right, so this particular part is quite important. Alright, then the last part for this question, part number 4. Okay, highlight the word given that. So again, you see the word given that tells you that it is conditional probability. Alright, so maybe before you continue to get the answer from me, you can maybe pause the video for a while and try to answer this question before checking your answer with my answer. Alright? Okay, so given that the person chosen is unemployed, so unemployed, they want you to find the probability that the person is female. Alright, so for conditional probability, from a two-way table, please look for the intersection of female and unemployed. So the intersection between female and unemployed unemployed is 358. Divided not by the grand total, but you are looking for the total of unemployed person, right? So you look for total of unemployed, which is 564. So you should divide it by 564. Simplify the answer, you will get 0.635. Do you get the answer correctly?